Today we'll be going over chapter 5, section 7, natural logarithmic function. Specifically, we're going to talk about integration. Okay, natural log. So we're going to talk about ln, right? So here's the first thing I want to make sure that you remember before we get started today. If I give you the following problem, we talked about this last class. Do you see how this would be the natural log of u plus c? How do I know that, for those of you that are not seeing it? So can anybody tell me how I know that this go together? Well, the derivative of ln of u is 1 over u. But let's say you don't remember that. How can you tell just from looking at this? Good. Now, what I want to make sure, so for those of you that are watching the video and you didn't really hear what she said, let me kind of take you back and remind you and go back to just differentiation. So if I give you f of x, and I tell you that f of x is natural log of x, we'll go back to your rules of differentiation. You know that the rule of differentiation says that the derivative in terms of x of natural log of u is equal to what? Say that one more time. U prime over u. I'm going to use this to help me out. I'm going to go back here. Notice how the top is u prime, and this is u. Okay, I'm going to go back here. What's the derivative of u? Yeah, it is 1. And do you see how it's up there? That lets me know that because this is the derivative of u, this is going to be the natural log of the denominator, according to this rule going backwards. Cool? That's what's going to happen for the majority of the time today. So this rule right here is going to become very important for you today. Recognizing that 1 over u is the integral of 1 over u du is equal to natural log of u plus c. Okay? Now, where I want to start today is you should already have memorized the integral of, for example, cosine x dx. What is that equal to? Sine or negative? Positive sine x plus c, right? Because the derivative of sine x would be positive cosine, right? You should already know that the integral or the antiderivative of sine x dx is equal to what? Negative cosine x plus c. However, we haven't really discovered what the integral, for example, of tangent x dx is. We don't know that one yet. But now that I kind of showed you what we started with, we can figure it out. Because if you use your knowledge of trigonometry, you can rewrite tangent as what over what? Interesting. Cosine is in the denominator. What's the derivative of cosine? Negative sine, which is up there. Right? So you can let the following, so if you don't see it, you can say, well, let me let u equal to cosine of x. Right? So if I do that, then I know that the derivative of u is equal to negative sine x dx. Agreed? Now, if I can get rid of that negative, it would be negative du equals to sine x dx. Agreed? Now, if I go back and I use this information here and this information here, I can rewrite this problem. I can rewrite it as the integral of, first of all, sine x dx, right here, sine x dx became negative du, right? So I'm going to pull out the negative, and I'm going to put the du at the end. And technically, I'm left with 1 over cosine x, right? Well, what's cosine x? Do you recognize that? Ln of u. So it's negative ln of u plus c. Go back and substitute u. What is it? Cosine x plus c. So now you know that the integral of tangent of x is equal to the negative natural log of cosine of x plus c. Cool? Based on what I just showed you, then you should be able to find the integral of cotangent of x dx. So if you're watching the video, go ahead and pause it and try to figure out what the integral of cotangent of x dx is. Alright, I'm assuming you've already tried this at home, so let's go ahead and try it. So this is the integral of cosine x over sine x dx. I am noticing that the derivative of sine is cosine. Because then that's true, that lets me know that this would be the natural log of sine x plus c. We're good? That's 4 out of the 6 trig ratios. That means we still have to talk about secant and cosecant. Okay? Go ahead and flip the page. And let's talk about the integral of secant x dx. Well, it would make sense that we're going to try what we just did with tangent and cotangent, right? If I rewrite this, I would have secant is 1 over cosine x dx. But the moment I wrote it like that, it's very obvious that it's not going to work though, like tangent and cotangent. Alright? The derivative of cosine is definitely not 1. Yes, sir. Square root of secant square x? Yeah. And then do what with that? Okay. I see what, okay, there's nothing wrong with what he said. Square root of secant square x is the same thing as secant square x. I mean, as secant x, I'm sorry. But then remember, like, he was trying to let u be secant x, right? But then you gotta have the derivative of that, which would be secant tangent, which is not in there. So, actually, that brings me to a good idea. We need to have somehow secant tangent in here, so that we can help ourselves out. So how can I make secant tangent appear? You could just do secant x times tangent x over tangent x. So multiply by tangent x over tangent x. Is that multiplying by 1, right? Now the problem with that is, I tried it before we came, we're doing this lesson, so I would get secant tangent over secant, right? So then the derivative of secant, secant tangent over tangent, right? But now I have on the denominator tangent, and the derivative of tangent is secant square, which is not happening, right? It's not on the actual integral. So now, if we're going to bring in tangent, then we also need to not only make secant tangent happen, we also need secant square to happen. So any thoughts of how I can make that occur? So multiply it by tan secant over tan secant. Tan secant, is that a form of 1? Yes, but then at that point, we're missing one step. And I'm going to help you out, okay? I am going to need tangent and secant, but what if I do this? Is that a form of 1? Am I multiplying by 1? Okay. Now check out what happens. If I multiply those two together, what happens to the numerator? Tangent x, secant x, plus secant squared x. Does anyone recognize both of those? Fantastic. And what's on the denominator? Tangent x plus secant x dx. And I'm very happy with what I'm seeing right now. I have a fraction. I'm going to begin my process. I'm like, wait a second. What's the derivative of tangent x? Oh, there it is. What's the derivative of secant x? Oops, there it is. So when the derivative of the denominator is on the numerator, what is it? 1 over u. What's the integral? Now, I have been forgotten to put the absolute value on our previous problems. Why would I need an absolute value with a natural log? Because you can't take the natural log of a negative number. Cool? So we need to put the absolute value symbols with our natural logs. Now, for those of you that are watching, you're like, I don't understand what happened. Okay, here you go. Your denominator is u equals to tangent x plus secant x. If I take the derivative of that, what's the derivative of tangent x? Well, that's going to be secant square x. what's the derivative of secant x? Well, that's secant x tangent x, and this would be dx. Notice how this is exactly what you have on your numerator, and that is the reason why this would be a natural log. Okay? Questions? Do you think you're capable, based like this would be like the exact same process, very, very similar, just one minor change. Can you figure out what the integral of cosecant of x dx is equal to?
So it would be cotangent minus cosecant. I bet it's minus.
Try it. Try it. Alright, so I'm assuming you've already tried it. Now I'm going to use kind of the same strategy that I did for seeking, and I'm going to try to rewrite this. One of the things you should notice is, first of all, is that the derivative of cosecant of x is cosecant cotangent. Right? Negative cosecant x cotangent x. Now, in order for me to make that happen, it's going to be the same situation over here. So now I'm going to need the derivative of cotangent, right? Which is negative cosecant squared. So what would I have to multiply by to make that happen? Any thoughts? Cotangent plus cosecant? Okay. Cotangent x plus cosecant x over cotangent x plus cosecant x. Now, if I do such step, what is your new numerator? Cotangent x cosecant x plus cosecant square x over cotangent of x plus cosecant of x dx. Now, when I see that, I notice that it's almost what I need. Now, if you don't see what I'm talking about, let u be the denominator. Cotangent x plus cosecant of x. If you take the derivative of that, what is the derivative of cotangent of x? Negative cosecant squared of x. And what is the derivative of cosecant of x? Negative cosecant x cotangent x. Do you notice how this, dx, right? This is very similar to what I have on the numerator there, except that it's negative. So to make this happen, what if I factor out a negative and then make it a positive? So then I would have cotangent x cosecant x plus cosecant squared of x dx. This matches exactly what I have there. Therefore, I can rewrite this as negative on the outside of the integral, 1 over u du. What is the integral of 1 over u? ln. So it's going to be natural log of the absolute value. I'm going to go ahead and replace the u with what we had originally, which was cotangent x plus cosecant x. And do not forget your constant of integration.
So does that mean the slope will always be negative?
Pretty much. Alright, we're good? So now you know how to integrate all 6 trigonometric functions: sine, cosine, tangent, cotangent, secant, and cosecant. What's up?
I don't think it'll, because that's the area under the curve of that, right?
No.
No?
Remember, what's area under the curve? What type of integral?
Oh,
A definite integral. This is not area under the curve. This is just an antiderivative. Okay? So be careful. Do not confuse one with the other. Remember, I know they use the same symbol, and that's what confuses a lot of people. But a definite integral gives you area. An indefinite integral is just an antiderivative. Cool? Alright, yes sir.
Is this like the replacement for the quotient? Like replacing?
I wouldn't want to think about it that way, because one of the things I want to make sure that you understand is that there is no such thing as a product rule of integration. There's no such thing as a quotient rule of integration, and there's no such thing as a chain rule of integration.
well, we already did.
We are doing, in order to take care of that, we have to use strategies. And the strategies that we've learned is to do u-substitution, right? So through the use of substitution, you're able to undo some of those products, quotients, and chain rules per se, okay? Alright, now we're going to just start practicing some problems where hopefully you'll recognize the patterns and recognize how natural law comes into play, okay? Alright, so let's go ahead and turn the page, and we'll start out with a very easy basic one, Okay, so hopefully it should be very obvious from the beginning. The integral of 3 over 3x plus 2 dx. The integral of 3 over 3x plus 2 dx. Natural log of the absolute value of 3x plus 2 plus c. Well, look at this. Let u be the denominator. What's the derivative of the denominator? 3 dx. That's what you have on your numerator. So there's really not need for, by the way, there's no need for you to do all this. If you need to, absolutely do it. You're learning this for the first time. But once you practice this enough, like if this was an FRQ, which I really doubt, they're not going to check your work. Like if you can go from there to there, they totally understand that. Okay? So that one's, like I said, very basic problem, easy one. Cool? Alright, next example. Let's do the integral of 2x to the third power plus 3x divided by x to the fourth power plus 3x squared dx. Okay. Remember, every time you're dealing with a quotient, the first thing I would recommend that you check for is to see if the derivative of the denominator is present. Well, what's the derivative of the denominator? 4x cubed plus 6x.
So you multiply by
Now,
2 on top and bottom.
I am noticing the following. I do have the cubed, I do have the first power, but this is, according to the derivative here, this would have to be a 4 and this would have to be a 6. So, what if I do, and I think I heard you guys say, like if I could just make this multiply by 2, then that would be great, right? But if I just multiply by 2, that totally changes things, right? What if I do this? What if I multiply by
2 and then a half.
2, but throw a 1/2 on the outside?
Wait, you mean 2, right?
Because 2 times a half is what? 1. Have I changed anything?
No.
So check this out. Now I have a 1/2 on the outside. And integral, if I multiply in a half, 4x to the third plus 6x over x to the fourth power plus 3x squared dx. Now, check again. The derivative of the denominator is 4x to the third plus 6x.
So it's a half.
Therefore, your answer would be
Half ln absolute value x to the 4th plus 3x squared plus c.
plus c. Now, if you're like, you know what, I don't think I'm gonna, I don't think I can do all that, like that's too much creativity, well, you can still use u-substitution, let u be the denominator, right? Agreed? And then you do du would be 4x to the third plus 6x dx. Now, you are going to compare that to what you have here. You want this to happen, so couldn't you just divide by 2? And that's where you have the 1/2 du equals to 2x to the third plus 3x dx. And he gives you the same answer, and that's where the 1/2 is coming from. We're going to pull it out of the integral. So if you don't like this whole like trying to get creative and multiplying by some form of 1, you can always go to u and do the u-substitution. Okay? Alright, next one. We're just going to practice a bunch today. I'm sorry, guys. What is the integral of 3x squared plus x minus 1 divided by x plus 2 dx?
What?
Okay, so the first thing I'm going to check is that it's a quotient. I'm going to check that the derivative of the denominator is the numerator. And for this one, it's very obvious that it's not happening. It isn't, right? Now, there is no such rule that the derivative of the numerator is on the denominator. There's no such rule as that, okay?
Even then it wouldn't work.
So, and even then it wouldn't work. So now I'm going to have to get creative with this. And it's all about how much algebra you know. Well, if you analyze the graph of this, you have a higher degree on the numerator than the denominator, so this has a slant asymptote. And how do you find the slant asymptote? So what if I do division to maybe rewrite this problem? Okay, you ready? Check this out. So can I use synthetic, by the way? Okay, cool.
X plus 2 times 3x.
I'm going to have a 3, a 1, and a negative 1. And what will go outside? Negative 2. Bring down the 3. 3 times negative 2 is negative 6 plus 1. Negative 5 times negative 2. 10 minus 1. Now that means you have a remainder, right? So technically, by me taking this divided by that, now I can rewrite this integral as 3x minus 5 plus 9 over x plus 2 dx. And now I look at this and I'm very happy with what I see. I know how to integrate that. I know how to integrate that. And I definitely know how to integrate that because this, the derivative of this would be 1, which is technically up there. Take out the 9, right? So here we go. If you're not seeing it, you can do the following. Well, I think you can take care of this for sure, right? Okay, what happens here of the integral of that?
It goes to
3 halves x squared
minus 5x.
minus 5x. And let's just pretend you still don't see it here, so let's say plus the integral of 9 over x plus 2 dx. Yes? Do you see a constant? Can you pull out the constant? Well, the denominator is x plus 2. What's the derivative of the denominator? 1. There it is. So what does that tell you?
So it's 9 ln x.
Plus c. Cool? Now, I'm going to be realistic with you. And you might see, like, how do you see all these things? How do you know when to do this? How do you know when to do that? How do you, like, after today, you're going to be like, I don't understand how you're seeing this, and when do I know when to use this? When do I know when to do that? And the only answer that I can give you at this point is you're not going to see it unless you practice. Unfortunately, you've reached a level in math where if you're someone that can just follow step 1 to step 2 and step 3, in other words, if you need a recipe to get to the answer, you're in calculus now, and that doesn't work always. Now you're going to have to get creative, right? And this is sometimes when I have a lot of people that are really good at math, but that was because they're great at following steps. And unfortunately, now you're telling them, like, hey, there's no steps anymore. Now you really have to analyze and use all your knowledge of algebra to help you out, and that's what makes this subject hard. Just that, the algebra, it's not even the calculus. You know how to integrate, okay? So make sure this is going to be essential for this test. You have got to practice and practice and practice and practice. With practice, you're going to see patterns and you're going to recognize things. Okay? Yes, sir.
Is it kind of like geometry where like you have to draw like extra lines and shapes?
Sure. Yeah. All right. Anyways, moving on. I want you to, I'm just going to give you one. I'm going to see, like, I'm going to try to let you just get creative with it. Okay? So I'll give you some time to try this one on your own before we go over it. So let's do the integral of 3x divided by the square root of 16 minus x squared dx. So we'll go ahead and pause the video. Try this on your own.
Make it like 85 for partial.
All right, let's go over this. So very quickly, I'm going to let u equal to 16 minus x squared. If I take the derivative of that, I get negative 2x dx. It's not exactly what I have here, but I can make it happen. So how can I get this to be at 3x?
Multiply by negative 3 halves.
I can multiply both sides by negative 3 halves. Now if I do negative 3 halves times negative 2x dx, then I get negative 3 halves du equals to what?
3x dx.
3x dx, which is what I have on this problem. So now here I can go ahead and rewrite this as the integral. Now 3x dx becomes negative 3 over 2 du, but I can pull out the negative 3 over 2, right? And I can leave the du. And technically then I would have what left?
1 over square root of u.
1 over the square root of u, not 1 over u, right? If it was 1 over u, it would be natural log of u, right? But it's not 1 over u, it's 1 over the square root of u. So what can you do there? No, you'll be changing the problem. Very good. U to the negative 1/2. And now you know how to anti-differentiate that. You add 1, so that becomes u to the 1/2. 1 divided by 1/2 is 2, plus c, right? Now, negative 3/2 times 2 is going to be negative 3 square root of, what's u? 16 minus x squared plus c. Okay? So I showed you this problem just to make sure that you understand, just because you have a quotient to begin with doesn't mean you're going to have a natural log. Okay? Alright, let's continue then. What is the integral of square root of x over square root of x plus 2 dx? Square root of x over the square root of x plus 2 dx.
Square root x plus 2, or like square root x is its own thing, plus 2 is its own thing?
It's its own thing. Any thoughts?
Split up into two fractions.
Do what, I'm sorry?
Split it up into two fractions.
I can't do that. I can't split the denominator.
Oh, right.
If it was the numerator, I could, but I can't do that. Well, no, I can't do that. Sorry, I was trying to think maybe partial fraction decomp, but no, I can't do partial fraction decomp on that.
No.
That's coming very soon. Anyways, I can't split this up into two fractions. So divide everything by square root of x. So let me see if I understand this correctly. So you're saying take square root of x and divide it by square root of x, and then do square root of x divided by square root of x, and then 2 divided by square root of x. I don't know, we'll see. I've actually never tried that, so we'll see. I don't know. No, I'm just doing what you suggested. I've never tried it. Maybe it'll work, maybe it won't. I don't know. Okay? Alright. Square root of x over square root of x is? Square root of x, so that's 1 plus 2 over root x dx. Okay. But like, my problem is that we still have this issue of like having something over that, right? Like, it's still kind of the same scenario per se, just written differently.
Wouldn't that equal 1 plus root x over 2?
Okay. I'm just trying to see. I'm trying to analyze this. I'll come back to this. Hold on. So, you said let u be what, I'm sorry?
U over u plus 2. U is square root x.
So let u equal to root x, and then do u over u plus 2. But then again, we have the same situation, right, where you have the three terms, right? You're just changing, you know what I'm saying? You're just changing x for root x for u. Any thoughts?
Wait, what if you do synthetic division?
Synthetic division? I can't because I don't have a linear factor.
Oh, right.
Right? There's the same power. So there's no reason for us to use division here. What do you think?
Do square root of x over u, and then the derivative of...
So let u be then square root of x plus 2?
The derivative would be like 1 over maybe... I don't know.
Okay, what do you got? Conjugates? Interesting.
Oh no.
Interesting. I don't know, let's try it. Maybe.
Set up for it to work.
Sorry. Okay, what would be the conjugate?
Root x minus 2.
Is that a form of 1?
Yeah.
Okay. Pre-cal really loves the conjugate, man. They really do. Okay, what would happen then here?
X minus 2 root x.
So x minus 2 root x over what?
X minus 4.
X minus 4? dx?
And now you can split into two fractions.
I mean, we could. I mean, if we split into two fractions, I would have x over x minus 4
Oh, never mind.
minus 2 root x over x minus 4 dx. Ugh, I don't like where this took us. Okay, by the way, everything you've suggested, yes, we could go that route. It's just making the integral very difficult. So I'm going to go back to what we've been doing, which is let's think of u-substitution, okay? All right, so we're going to scratch. We tried it, but I don't think it's getting us anywhere. So let's say that we have...
What if a question like this was on the test, and like we didn't know how to...
That's why you got to practice a lot of times before you get to that test, right? So that when you get to the test, you see it right away. Yes, what do you... Melissa?
Well, I was going to say that, like, the derivative of x to the 1/2 is negative, x to the negative half is the derivative.
Oh.
Half is constant.
Right.
Wouldn't that be in the denominator?
That's just...
But there's not a rule that tells us that the derivative of the numerator is in the denominator, right?
Yeah.
Okay. All right. So here's what I'm going to do. I'm going to let u equal to the square root of x plus 2. And I'm here hoping that this will work. Like, this is just me trying things out. And I'm hoping it's going to work. Okay? So if I do that, then I can then say that the derivative of u would be what?
1 over 2 root
1 over 2 root
x.
x
Yeah.
dx. Okay. Let me see what I have and rewrite to see where I need to go to see if it even is going to work. Okay? So I have the integral. The denominator is for sure u. And I have root x dx. That's where I'm at the moment. Can I use this information here to help me out?
You could put root x in terms of d, or put du in terms of root x.
The thing is that we've already done this skill before, you're just not remembering. How about if I go back here and I say that u minus 2 equals to root x? Yes? We've already tried this before, it's just we haven't used it in a while, so we may forget it. So what's root x equal to?
U minus 2
Over u. But now, what is dx though? I still have this dx.
Isn't that just what we,
Well, we can go back here. Like, don't forget, we still have du equals to 1 over 2 root x dx, right?
Oh, 2 root x du equals dx. That means 2u du equals dx.
1 over 2u.
But now we know that root x is u minus 2.
Okay, you know.
2u du equals dx, right?
They cracked me up. All right, hold on.
That's so funny.
You're good. All right, what's root of x?
U.
So u minus 2? So you're telling me to do this. du equals to 1 over 2 u minus 2 dx. Is that what you're telling me to do?
Yeah, and then you multiply
Yes.
2u minus 2 to the other
So
side.
then do 2 u minus 2 du equals to dx.
Yeah.
I mean, algebraically, is that correct?
Yeah.
Sweet. So then the integral of u minus 2 over u times what?
Times 2u minus.
Can I pull out the 2, by the way?
Oh yeah.
Put the 2 out here, times u minus 2
The u minus
du.
du. Okay, I like where this is
Oh,
going.
and then you multiply together, and then you do the division.
Sort of.
Okay.
What's this times this?
u minus t
U
squared
minus,
over u.
yeah. U squared minus
U
4
squared
minus 4x.
minus 4u plus 4 over
U.
u du. And I see this and I'm very happy.
Why?
Well, what's u squared over u?
U.
What's negative 4u over u?
Minus 4. U, why, yeah. Yeah. Cool.
Yes?
Oh, and then, okay.
Okay, what's the integral of u?
Oh.
U over 2.
U squared over 2, right?
Minus
What's the integral? Minus 4u. Do
plus
you
4 ln u.
plus 4 ln u
After that.
plus c, and I still have to multiply by this 2 out here, don't forget that, right? So if I multiply by the 2, this 2 goes away, this becomes an 8, this becomes an 8, so what's your final answer? What was u to begin with?
Oh. Square root x plus 2.
Okay, so hold on, what's up?
You got C in the bracket there,
Yeah, but multiplying it by 2 is just another constant, right? So it's just a c.
but in reality, if we had a C, you would multiply that in the fraction?
You can, but I mean, like, don't write 2c at the end. It's just another constant. Because what we care is it's just a constant of integration. We never know what it is. 2 times c is just another constant, so you would just write c. So if we go back and replace, u was, I'm running out of space, I'm going to come up here, square root of x plus 2 squared, right? That's where I'm at right here. Minus 8 times square root of x plus 2 plus 8 times the natural log of the square root of x plus 2 plus c.
Do we have to simplify that?
No, just leave it like that. Just call it a win right there.
To be honest, I think you could simplify it.
Let's just leave it there. I mean, you can bring this 8 and make it to a power there to the properties of natural logs, but why? Just leave it there.
I think like if you expand.
Oh, yes, but let's not go there. No. This is not a test about your algebra skills. This is going to be about your calculus skills for the most, like, after this, I think you've done enough algebra to prove yourself, okay? All right, we're almost done for today, guys. It's been a long day.
Today we use like I use like 5 pages.
It's been a long day today. Tell me that I was recording. Is the timer moving? Oh, okay. Okay. Alright. Please. Alright, we technically have 4 problems left, but I'm just going to pick 2 of them. And I think you kind of get the idea of what's happening here. I'm definitely going to do a definite integral to make sure that we practice the fundamental theorem of calculus. And we're going to solve a differential equations just so that you don't forget your skills that you've learned in the past.
What are different?
So differential equation is when I give you the derivative. That's it, right? So let's say that I give you dy over dx is equal to secant of x tangent of x over secant x minus 1 such that it goes through the point pi over 3 comma 5. Somebody get the door. Thank you. Alright, so when I ask you to solve, what is this asking you to find?
Wait, what goes through pi over 3 over 5?
So that's my question. What is this asking you to find? Thank you, sir.
Oh, it's asking you to find like the constant and then you like.
Asking you to find f of x.
Yeah.
Like you're solving a differential equation. What is f of x? But this time, you're not going to have a constant of integration thanks to this point right here.
To plug it back
Right?
in.
So the first step to solve a differential equation is to get dx to the other side. And how am I going to do that? Multiply it. dy equals to secant x tangent x over secant x minus 1 dx. Now this is starting to look a little bit more like what we've been doing.
Because the derivative.
Now we're going to have to integrate both sides.
The derivative of secant x is on the new.
Okay. If we integrate dy, what is that?
Y.
Just y. Now remember, we've talked about this. Technically it's y plus a constant, but we don't need to put it because we're going to get a constant on this side. Agreed? Okay. So now this side, it's actually not such a terrible integral.
It's pretty easy.
Good. Why? For those of you that do not recognize it, do you see how u, if we let u be secant x minus 1, what's the derivative of that?
Oh,
Secant x tangent x dx, which we already have present. So you're telling me that this would be what? The natural log of what? Secant x minus 1
Wait, how would you do this without a calculator?
plus c. Hold on. That's where we're at, right?
Yeah.
Now we're going to plug in pi over 3. So now we know that f of pi over 3 is equal to the natural log of the absolute value of secant of pi over 3. Hopefully you did well in pre-cal and you remember your unit circle. Plus c, and that's got to be equal to 5. Agreed? Okay.
Oh, 2.
What is the secant of pi over 3? Well, I don't memorize my secants, but I know that secant goes with cosine. So the cosine of pi over 3 is 1/2. The reciprocal of 1/2 is 2.
Oh.
2 minus 1 is 1. So I am left with the natural log of 1 plus c equals to 5. What is the natural log of 1?
0.
0, which means then that c is equal to 5, and therefore what is your final answer?
Y equals ln secant x minus 1 plus 5.
So you gotta recognize that when I give you a differential equation, you're actually looking for f of x, or whatever variable you're dealing with, without the constant of integration. You will be, if you're given a point, obviously. If you're not given a point, then you still have the plus c. Yes, sir.
When you put f of pi over 3, could you have not put f of pi over 3 and just put 5 on that side? Or just
Sure.
leave 5?
It doesn't matter. I just like to make sure that you understand what I'm doing. That's all. Cool? Alright. How we doing? Alright, that leaves us with 6 minutes left in class. Perfect. For one last problem, and we'll call it a day.
Okay.
Whew. Let's do a definite integral. So a definite integral helps you find what?
Area under curve.
So we're going to find the area under the curve. So I want to figure out what is the area under the curve between 1 and e squared of 2 plus the natural log of x. All of that I want it to be squared over 3x dx. Okay, since we have such limited amount of time, I'm just going to go ahead and jump in without giving you some time to try it. I apologize. I know you're dying to try this on your own. What if we do this? What if we let u equal 2 plus the natural log of x? So if I do that, then that means that the derivative of this would be what? 1 over x dx, which I see present here. Because we can rewrite this as the integral from 1 to e squared of 1 over 3x times 2 plus ln x squared dx. You guys agree that's the same thing?
So you take it 1/3.
We can take out a 1/3. Agreed? So then I can take out a 1/3, and I have the integral from 1 to e squared of 1 over x times 2 plus the natural log of x squared dx. Do you see what happens?
It's u du.
1x dx right here becomes du, and this right here becomes u squared. Right? So then that means I have the integral, so 1/3 times the definite integral of 1 e squared of u squared du. Remember how at the beginning of class I told you that how we can make this easier? Can we switch this here? I'm going to go back to my beginning statement. You know that u equals to 2 plus ln of x, right? So let's say I want to figure out what this top one is, right? So u equals to 2 plus the natural log of e squared, right? What is that equal to? 4. Very good. And now u equals 2 plus the natural log of 1.
That's 2.
That's 2, right?
It always goes to
So now I can rewrite this as 1/3 integral of what to what?
from 2 to 4.
From 2 to 4 of u squared du. And I've made my life a lot easier because I don't have to go back to x, right? What is the integral of u squared?
1/3 u.
So 1/3 times 1/3 is going to be 1/9 u to the, evaluate from where to where? From 2 to 4, I'm sorry, right? Yes? And now this became a lot easier. So 1/9 times 4 to the 3rd power minus 1/9 times 4 to the 2nd power, right? Yes, it is. 4 to the 3rd power, for those of you that can't do math that
Wait,
fast.
It should be 2 cubed, not 4 squared.
Oh, I'm sorry. Thank you. 2, sorry. I'm just, oh no, come on. 2 to the 3rd power, I'm sorry. So 4 to the 3rd power is 64, so that'll be 64 divided by 9 minus 8/9. So at that point you would have 56/9 units squared, since we're talking about area.
Do we have to put units squared every time?
Yes, please.
Even on the test?
Yes, please. And that, my friends, is 5.7. We'll go over 5.8 next class. Expect to maybe have a skills check next class. Maybe, maybe not. We'll see.
You can